Solubility curve notes. Reading graphs. Solubility curves. A solubility curve is a graph showing the amount of a solute that can be dissolved at different temperatures in 100 grams of water. This is an example. This graph shows KNO3 as it dissolves in 100 grams of water. On the x-axis, the graph lists different temperature values in degrees Celsius. On the y-axis, it lists the mass of solute that can be dissolved in 100 grams of water. About how many grams of KNO3 can be dissolved at 40 degrees Celsius in 100 grams of water according to the graph? Between 60 and 80 grams. Positions on the graph. Depending on where a point lands on the graph, it means something about how much of the solute is dissolved in water. If the point is below the curve, between the line and the x-axis, the solution is considered to be unsaturated. If the point is on the curve, exactly on the line, the solution is considered to be saturated. If the point is above the curve, higher than the line on the graph, the solution is considered to be saturated. And any extra solute collects at the bottom of the container. The extra solute is referred to as excess. Saturated, unsaturated, and supersaturated. Continuing on from the ideas of the last slide. Unsaturated. If a solution is unsaturated, it means that too little solution is dissolved and more can dissolve. Again, this is if the plotted point falls below the curve. Saturated. A solution is saturated if it has the maximum amount of solute dissolved under normal conditions. No more solute can dissolve, and any extra added just sinks to the bottom of the container. This is if the point lands on the curve. Supersaturated. These are solutions with more than the normal amount of solute dissolved. They cannot be found with a graph because the graph only assumes normal condition. Video of supersaturated solution.
Zoom in, Rena. I don't know how. Go closer. Hold on.
Just start.
I can't even see it. Okay, go.
Hardly see.
Okay, well there's a crystal on it. You might crystallize your. Okay. It's not gonna crystallize on your phone.
Ready?
Yes.
So realize this has been sitting there all year long like this. Okay.
What is it?
I'm
What
gonna
is it?
change it. Huh? Well, it's water that has a huge amount of these crystals dissolved in it.
Oh.
It has so much of it that it's called supersaturated. It actually is holding more salt than water actually can. How does that work? Because I boiled it.
You dropped it in there?
Oh!
Oh snap! Oh my gosh, that's so cool!
It looks like
It looks like a puffball. My finger ran out of it. Oh my god. Oh my god.
That's so cool.
What happened to the bug? What happens if it's still over there?
That's so
Ow.
cool.
That was just one drop.
One crystal.
Look at it extending from the bottom. Oh, that one's racing. It's racing. Look, that one's Jeremy. He got it.
Yeah, I get there first.
Watch it. I want to see my nail. I want my nail to be in the picture. Oh my gosh. Oh my god. This is giving me goosebumps. It does look kind of weird. This is so cool. Is this real? They look like feathers. Can we touch it? Are we gonna
Wait till it's all crystallized.
You would touch it either way, but I touch radioactive things. Oh my gosh, poor Austin. You can't see it like that. Rena, stop.
He's having more fun.
Are you gonna break it off and give pieces to all of us? Could we both have touched it?
Well, first touch the sides.
Is it cold?
I should have had you touch the sides before.
Yeah, it's not even like frozen. It's not cold.
Not cold, it's warm.
Yeah.
It warmed up. So the crystallization process actually releases heat.
Oh. Just gross stuff. Why is it going to look like that? It's gross stuff in here. Can we really?
What is the means for this graph? If a solution is unsaturated, more solute can be added. More can be added until it reaches the amount the line shows. If a solution has too much solute added, the amount over the line will stay as a solid at the bottom of the container. Here again, we see the solubility curve for KNO3. When I say the line, I mean the curve, the black curve that extends across this graph. Now, if this solution is made at 40 degrees Celsius with 50 grams of KNO3, could more solute be dissolved? If yes, approximately how much more? Remember, temperature is on the x-axis and the grams of KNO3 are on the y-axis. Yes, approximately 20 grams or more can be added before it's saturated. If this solution is made at 60 degrees Celsius with 150 grams of KNO3, approximately how much solute would be excess and collect at the bottom of the container? Approximately 30 grams of solute. Cooling or heating a solution with a curve. Solutions can change their temperature because they are not static. When this happens, sometimes the amount of solute that can be dissolved in the solution. To find out how much solution turns back into solid or how much more solute can be dissolved, we subtract the old maximum amount of solute dissolved from the new amount of solute that can be dissolved. A positive answer means that many more grams of solute can be dissolved. A negative answer means that many grams of solute turn back into solid. Multiple curve graphs. This is the most common type of solubility graph that you will see. Sometimes a graph will show many curves on the same plot area to allow you to compare the solubility of different chemicals. There is no difference between this and a single line graph. You just need to focus on one or two chemicals at a time. When asked about a specific chemical, ignore all the others. They will not influence your answer unless specifically mentioned in the question. Practice. Here is an example of a multiple solubility curve graph. What solute has the lowest solubility at 10 degrees Celsius? KClO3. How much NH4Cl can be dissolved in 100 grams of water at 50 degrees? $50 grams. At 30 degrees Celsius, is 70 grams of KNO3 dissolved in 100 grams of water? Is this solution saturated or unsaturated? How much solute is in excess, or how much more can be dissolved? This solution is saturated. 20 grams of solute are in excess. At 70 degrees Celsius, 100 grams of KNO3 are dissolved in 100 grams of water. Is the solution saturated or unsaturated? How much solute is in excess, or how much more can be dissolved? This is an example of an unsaturated solution. 40 more grams of KNO3 can still dissolve.